Welcome to That Fabric Guide. Today we are going to look at the performance differences between an F2 capacity in Microsoft Fabric and an F64 capacity in Fabric. So what we're going to do is we're going to load a large data set that's almost 300 million lines of data into a Delta table using a notebook. We do an initial seed of about a quarter of that data. And then the second run that we do is a full load of that 300 million lines. And we will be merging it into the same Delta table based on a key. In the query there's also some mapping, some joins. So we're going to give the F2 and the F64 a run for their money. And let's see if the F64 is that much faster than an F2. So let's dive right into my laptop. First of all, let's confirm that we have a running capacity. It says here that I can pause it so it is running. And in here we can see that the SKU that we have selected is an F2. So that's actually good. Now let's go into my performance testing folder here. And let's look at what we are working with. Let's start with the F2 because the capacity is running an F2. We have our notebook right here. We are connected to the Performance Lakehouse. We have a few shortcutted tables that we are going to read out of. And the notebook, the Lakehouse that we're reading out of is running on the same capacity. So that's no factor here in this test that we're doing. Now let's remove these warnings. We are going to write into a table called Performance F2 and we're going to merge based on a key column called PK. Now we have the same mapping that I used in a previous video right here, only I added a filter saying the pickup date should be on or equal should be equal to or lower than the 31st of March 2024. Now this is a 2024 dataset with 295 million rows of data. So we're loading only the first 3 months for this initial load. And then we're writing the output of that mapping query to a Delta table in the Lakehouse with the name Performance F2. Now this should all be very, very easy. The second load that we're going to do is the merge load. And in the merge load, we're going to do basically the same query. The only thing is that I now commented out the pickup dates filter. So we're going to merge the entire table. That means that we have to merge a quarter of the data. We have to upsert that data. And then for the rest of the data, it should be inserted. And we're going to use a Python merge in order to do that. We discussed this in another video as well. Okay, let's get started with the initial load and let's find out how fast this actually will go. And we're including the session startup times for this performance test, but they are a few seconds as you can see here. And now I expect the mapping here to take quite a while because it's a lot of data to go through. It has to join two separate tables and then it has to filter the result set that we're getting out of this. So we're reading from a 300 million line or 295 million line table. We're not outputting 295 million rows because we're filtering here for writes that go to other burrows. All right, so actually in 31 seconds this mapping was done on an F2. That's actually really fast, so I'm quite happy with that. And we're now writing into a new table. And within 95 seconds, the writing of that table was completed. And that means that we have 14 seconds plus 31 seconds plus 59 seconds in here. That means that our entire session on the F2 ran for about 1 minute and 44 seconds. So that's actually pretty okay. Let's look at our tables in here to verify that the table has been created. And indeed, we have now our Performance F2 table in here. Okay, that looks great. Let's quit this session and go to our F2 merge. Let's figure out whether, yes, the Performance F2 is actually there. That's good. And now, mind you, we are actually looking at the same tables in here. We removed the pickup date filter from here and we added this merge. Now I expect this cell right here to run a little bit slower because it needs to load more data into the data frame. And then the merge, I'm not sure what's going to happen here. It will probably also take some time. There we go. The session is starting. We have the same 13 seconds or 14 seconds it was, I think, the last time, but we have the same cell execution time here basically. And now we suspect this one to run a little bit slower than the 31 seconds that we used to have. So actually this is now 17 seconds. It's a lot faster, and maybe that is because reading the entire table into memory is faster than looking through that table to filter on the pickup date. That could be the case. Now, because of the error we got, I made a copy-paste error. We have to rerun this cell, and let's just run this cell again and not do everything at once. And now the session has been finished. But after 2 minutes and 19 seconds, we actually got something. So that is a total runtime of 2 minutes and 49 seconds. Now that is the time that the F64 has to beat. So let's quit this session right here. We will go into our capacity and scale it up to an F64. Now with the F64, you might think you get more compute power, more resources, more CPU and memory and so on. And while that is the case, it's not necessarily the case. So you're not really purchasing hardware that can do tasks for you or do compute for you. You're purchasing a bundle of compute usage, basically. So the thing with the performance is, even though we buy a larger bundle of compute, we do not necessarily get more compute resources. Maybe we do, maybe we don't. That depends a little bit on how the parallelization of the query can be handled, because an F64 has the option to scale out a little bit faster and a little bit better than the F2. So I do suspect a faster performance, but the performance will probably not be scaling linearly. We will not see a 30 times increase in speed. But let's find out. We are now running on F64 capacity, as we can see here. Let's go double check our merge here, that we don't have the same errors that we had in the past. We have our F64 right here. It is there's no filter for the merge version, and then we should change our DF mapping. And let's also put the performance testing merge. Let's also put the import that we had right here, like so. All right, this now looks good. It's saved, we can close that. Let's go to the initial and double check everything's valid here. That seems to be working. This all looks good, this all looks good. Performs F64, let's go. The session was ready in 10 seconds instead of 13 seconds. That is only 3 seconds faster. It is a bit faster in terms of percentage increase. I'm not sure whether that's due to a larger capacity though. Let's find out if we can beat the 31-second runtime for the mapping query that we had on the F2 initial load. It is actually a little bit slower at 33 seconds. However, those 33 seconds, I don't think they're meaningfully slower. And this is probably due to the single-threaded nature of reading a dataset into memory, especially with a dataset of this size. Now, 300 million is not nothing, but it's also not really, really big. So probably the F64, yes, it can scale out a little bit faster. It can get more concurrency, but probably for this query that didn't help. Now let's see what the thing here is going to do for creating the new table, and I suspect it to be around the same time as well. And then I hope that on the merge we can see that the merge actually is a lot faster than on the F2. So this was around the same time. We are at a minute and 43 seconds, which is the exact same runtime that we had on the F2 initial load. So let's kill that and go on to the F64 merge. There we are. And one final check. This all looks good. This all looks good. And let's go. Now, as I mentioned, probably we will see most of the performance increase on this final cell in here. Session ready in just under 12 seconds. That's all right. 16 seconds. Now, I don't remember whether that's actually faster than the other one or not. But now let's see. This is where the real test is, basically, on this merge statement. Let's open that F2 merge to see what the actual runtimes were. Yeah, we had 17 seconds on the query. That's about the same time. And then we had 2 minutes 19 on the merge. So 16 seconds on the query here. It's slightly faster, but not meaningfully, and probably not because of the larger capacity. 2 minutes 19 is the time to beat for the merge. And we're coming up on the 2:19. I don't think the F64 is actually faster in this scenario, which is interesting. And there we are. We are now crossing the 2:19, and actually we are looking at a slower execution for the F64 at 2 minutes 27 seconds. This is something I did not expect to happen. I would have expected this merge statement to run a little bit faster on the F64 than on the F2. However, this is probably due to having a too small of a data set to actually challenge the capacities in any meaningful way, and therefore the F64 using the same number of compute nodes as the F2, and therefore we're not seeing any differences in speed. Now, in practice though, a data platform rarely runs only one process or runs a few processes linearly, right? Usually you will do a spin up of a lot of sessions at the same time, where you will run, I don't know, the extraction of 100 API endpoints at once, all at once. And what you will see there is that concurrency changes between the F2 and highest queues. So an F64 will probably be faster right there, because you will see a higher concurrency. You can maybe run 50 endpoints all at once instead of having only 10 all at once. I don't know the exact numbers, but this is something where the speed benefit of an F64 will come from in practice. Now, if you like this video, give me a thumbs up, subscribe to the channel as well, and I'll see you next week.